Hello and welcome guys to my YouTube channel. In this video we will be covering HCF and LCM, highest common factor and the lowest common multiple. Now let's start with HCF. So what is the highest common factor? Now let's say you had two numbers, 12 and 30. The highest common factor would be the number that can divide both 12 and 30, right? But the biggest number that can divide both of them. So the biggest factor between them, okay? So to get the idea, I will list out the factors of 12. So what numbers can divide 12? 1 can divide it, 2 can, gives you 6, 3 can, gives you 4, and 4 gives you 3. Finally, 6 gives you 1. All right, so, sorry, 6 gives you 2. And finally, 12, okay? So those are the factors of 12. Those are all the integer numbers that would be able to divide 12. Now, 30, we have 1, we have 2, 3 divides it as well, 4 doesn't, 5 does, and 6 does, 7 doesn't, 8 doesn't, 9 doesn't, 10 does, and finally 15 and 30 do, okay? So all of those are the factors of 30. Now, let's see, so here you have 1 and 1, so 1 is a common factor, yes. 2 and 2, they're both common factors, but they're not the highest factors. You've got 3 and 3. Then we have 6 and 6, and actually 6 is the highest common factor, okay? So we have multiple factors between them, but none of them are the highest. Only one can be, which is the 6. Okay, so I can say that for 12 and 30, HCF, the highest common factor is 6, okay? So hopefully this makes you understand the idea behind what the highest common factor is. Now, it would be impractical to do this method for very large numbers, so how do we do it? Well, we use the product of prime factors, okay? So let's take an example. So find the highest common factor of 70 and 90. So what you should do is find the product prime factor for 70 and for 90. So for 70, we're dividing by 2, get 35. By 5, we get 7, and by 7, we get 1. So 70 is equal to 2 times 5 times 7. Okay. Now, for the 90, we've got 2, we get 45, 5 gives us 9, 3 gives us 3, and 3 finally gives us 1 over here, okay? So 90 is equal to 2 times 3 to the power of 2 times 5. Okay. I've reordered those so we can have the smaller base first, smaller number. Okay. By the way, there is a video about prime factorization. So if you haven't watched that, you should go and watch that first. Now, how will I find the highest common factor? Well, for the HCF, we will select firstly the common bases. Sorry, not powers. Let's just put it as common numbers, okay? So common numbers. So what are my common numbers between those two? Oh, I have 2, but that's it. Actually, wait, sorry. And I have a 5. I'm sorry, I didn't say it at first. Yes. So I have a 2 and I have a 5. So 2 and 5. All right. Now, secondly, lowest power. Lowest power for the 2 and lowest power for the 5. So if you take a look here, the 2 is only to the power of 1 and the 5 as well. So it just remains as 2 and 5, right? But if there was different powers, you should select the lowest one, okay? So what's the HCF? It's 2 times 5, which is 10. And this right here is the highest common factor. All right. Now let's take a look here. So I want to solve the highest common factor of 84, 126, and 210. So this is interesting. We have three numbers, but the process is still the same. So I will go ahead and write 84 over here, and I will put 2. This gives us 42. Another 2 gives us 21. 3 gives us 7. And 7, and get 1. All right, so 84 is equal to 2 to the power of 2 times 3 times 7. I will use those dots because it makes things neater. Now we have 126. 126 is an even number, so I can divide it by 2. It gives me 63. 63 divides by 3 gives you 21. By another 3 we get 7. By 7 we get 1. And so 126 is equal to 2 times 3 to the power of 2 times 7. All right. And finally, I have 210. So once again, we have an even number. So I will divide by 2, gives me 105. Now 105 divides by 3, it gives you 35. And 35 divides by 5 to give us 7, 7, and 1. Okay. So 210 is equal to 2 times 3 times 5 times 7. So now, like we've said, for HCF, firstly, you want the common numbers. All right, so let's list them out. So if you take a look here, we need the common between all of those three. So we have the 2 being common between them, 3, and 7. So as you can see here, the 5, neither 84 or 126 have it as one of its factors. So the common numbers are 2, 3, and 7. And don't forget the lowest power, okay? So for the 2, if you take here, we have a 2 power 2, 2 power 1, 2 power 1. So I'll take the lowest power, which is 2 power 1. So just 2. For the 3, the lowest power is also 3 to the power of 1. And for the 7, it's just 7 to the power of 1 as well. They're all 7 anyways. They don't have powers, okay? So it's 2 times 3. So HCF is going to be 2 times 3 times 7, which gives you 42. Okay, and this is the HCF. Hopefully this was clear. All right, now let's take a look at this example. So highest common factor for 8 and 15. So I will go ahead and factorize prime, find the prime product of 8. So it's going to be 2, gives you 4, another 2, gives you 2, and another 2, gives you 1. So 8 is equal to 2 to the power of 3. Now as for the 15, we're going to start with 3, gives us 5, and 5 gives us 1. So 15 is equal to 3 times 5, all right? So now, like we've said before, you need to look for the common number, okay? As you can see here, there is no common. You've got 2, you've got 3, you've got 5, nothing is common between them. So what do I do in this case? In that case, the highest common factor is 1. All right, because this is the highest number that can divide 8 and 15. Nothing else works. Okay? So this is a tricky case that might come up. Moving on to the lowest common multiple, LCM. Now let's start explaining what is the lowest common multiple. So let's say I gave you two numbers, 5 and 6, and I asked you to find the lowest common multiple. Now to find that, you'll firstly find the multiples of 5. So what are the multiples of 5? We got 5, and then 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Okay, I'm just going to stop here. Now, as for the 6, we got 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60, and I'll also stop here. So, now let's take a look here. The lowest common multiple is a multiple that is shared by both of them. And if you take a look here, nothing is shared up until here, right? So 30. And this is what the lowest common multiple is. It's 30, okay? It's not 60. It would be wrong to say 60 because it's not the lowest. Yes, it's common, but it's not the lowest. Because this is why you're looking for the lowest number, okay? So this is what the LCM. So the LCM of 5 and 6 is 30, okay? Now, once again, it would be impractical to list all the multiples and then choose. So how do we find the lowest common multiple more efficiently? We also use prime factorization. So find the lowest common multiple of 8 and 12. I will go ahead and factorize 8, prime factorize 8, and prime factorize 12. So this is 2, sorry, this should be 4. 8 divided by 2 is 4. 4 divided by 2 is 2. And finally, 2 divided by 2 is 1. Okay, so 8 is equal to 2 to the power of 3. Now for 12, divide this by 2, we get 6. Divide by another 2, we get 3. And divide by 3, we get 1. So 12 is equal to 2 to the power of 2 times 3. Now for the lowest common multiple, it's not like the HCF. In the HCF, we used to select the common. Here we select all the numbers. All right, so all the numbers would be 2 and 3. And the second thing is to select the highest powers. All right, so it's going to be for the 2, the highest power is 3, and for the 3, it's just 3. That's the highest power, okay? So as you can see, it's different only in the way we choose the numbers, right? So for LCM, we select all the numbers, while for HCF, only the common ones. For LCM, we select the highest powers, but for HCF, we select the lowest powers. In any case, the LCM is 2 to the power of 3 times 3, which gives us 24. This is the answer. Now let's find the lowest multiple for 3 numbers. I'll once again prime factorize each of those numbers. Now 7 is a prime number, so the prime factorization is simply 7. So 7 is equal to 7. As for the 14, we can divide by 2, gives us 7, and then by 7 we also get 1. So 14 is equal to 2 times 7. All right. Now for the 21, it's going to be 3. We get 7. Another 7, we get 1. So 21 is equal to 3 times 7. All right. By the way, again, this dot is multiplication. I hope nobody mistaked it as a decimal point. Now, again, so for the LCM, we need firstly the all the powers, all the numbers, and then the highest powers, right? So if I list all the numbers, they are 2, 3, and 7. That's everybody. Highest powers, it remains as 2, 3, and 7 because all the powers here are powers of 1, okay? So the LCM is 2 times 3 times 7, which gives us 42. This is the answer. All right, so here's a bunch of exercises. For each of them, you should find the HCF and the LCM, okay, for each pair of numbers. You should pause the video for each of them, try to find it on your own. Now I will solve it. We have 18 and 24. Let's prime factorize each of them. So for the 18, divide by 2, we get 9. Divide by 3, we get 3. And divide by 3, we get 1. So 18 is equal to 2 times 3 to the power of 2. As for the 24, divide by 2, we get 12, and by 2 we get 6, by 6, no, we can't divide by 6, it would be wrong, because it's not a prime. By 2 again, because 2 is a prime, so 3, and by 3 we get a 1. So 24 is equal to 2 to the power of 3 times 3, okay? So this is actually going to be an interesting application because we're finding both. So let's see. So firstly, the HCF, if you remember, common numbers firstly. Let's list the common numbers. They're 2 and 3. And secondly, lowest power. Lowest P for power, okay? What is the lowest power for 2? It's 2. And the lowest power for 3, we've got 3 to the power of 2 and 3, so 3. So the HCF is 2 times 3, which is 6. All right? Now for the LCM, we select all. So all of them would be 2 and 3 as well. Secondly, we select the highest. Let me fix this. The highest power, which in this case would be 2 to the power of 3, 3 to the power of 2. The highest power for the 2 was 2 to the power of 3, and the highest power for the 3 was 3 to the power of 2. And so LCM is equal to 2 to the power of 3 times 3 to the power of 2. You can either do this mentally or plug it on the calculator. Gives you 72 because this is 8 times 9, okay? All right, so let's take a look here. We've got 45 and 60. I will again prime factorize each of them. So for the 45, you can divide it by 3, we get 15. By 3 again, we get 5, and by 5, we get 1. So 45 is equal to 3 to the power of 2 times 5. As for the 60, dividing this by 2, we get 30. By 2 again, we get 15. And by 3, we get 5. And by 5, we get 1. So 60 is equal to 2 to the power of 2 times 3 times 5. Now let's find the HCF first. Oh, not right anymore. The first step is finding the common. What are the common ones? There are the 3 and the 5. And the second step is to choose the lowest power for these common ones. The lowest power for the 3 is 1. The lowest power for the 5 is 1. And so the HCF is 3 times 5, which is 15. Now the LCM, we select everything. So 2, 3, and 5. And we select the highest power for each of them. The highest power for 2 is 2 to the power of 2. The highest power for 3 is 3 to the power of 2. And the highest power for 5 is just 5 to the power of 1. And so the LCM is equal to 2 to the power of 2 times 3 to the power of 2 times 5, which is 4 times 9 times 5. You get 180. So those are my final answers. All right, so we've got 15 and 23. So let's take a look here. So 15, can divide this by 3, we get 5. By 5, we get 1. So 15 is equal to 3 times 5. Now, as for the 23, you can attempt 2, it won't work, 3 won't work, 5 won't work, 7 won't work either, and 11 won't work. And those are all the prime numbers below half of this number. So this is a prime. Okay. So the prime factorization of 23 is just straight up 23, okay? Now, HCF requires us to select the common. There is no common, is there? Because this is 23, this is 3, this is 5. So what is the HCF? It's just 1. because the 1 is the only common factor between all numbers, okay? Now, as for the LCM, we've got to select all the numbers. So this is the first step, 3, 5, and 23. Second step, select the highest power for all the numbers, which in this case is just 1, really, because they're all to the power of 1. So the LCM will be 3 times 5 times 23. And you can go ahead and plug that on the calculator. It gives you 345. All right, so now we're dealing with 3 pairs. I'm sorry, I mean 3 numbers. They're not 3 pairs. Okay, so you should again pause the video. Try to solve it on your own. So let's prime factorize each of those numbers, 12, 15, and 20. Now for the 12, we're going to divide by 2, we get 6. By 2, we get 3. By 3, we get 1. Over here, the 15 will divide it by 3, we get 5. By 5, we get 1. And then 20 will divide by 2, we get 10. By 2, we get 5. And by 5, we get 1. So now let's list them out. So 12 is equal to 2 to the power of 2 times 3. And 15 is equal to 3 times 5. And 20 is equal to 2 to the power of 2 times 5. All right, so for the HCF, as you remember, we'll select firstly the common. So what is the common here? Is the 2 common between them all? No. It's only between the first and last one. 3 is not common either, and neither is the 5. So we actually don't have any number that is common between them all. So the highest common factor is just 1. All right. Now, as for the LCM, the first step is to select all the numbers. So 2, 3, and 5. Second step, select the highest power for all these numbers. So 2, the highest power for it is power of 2. As for the 3, it's just power of 1. And the 5 is just a 5. And so my LCM is equal to 2 to the power of 2 times 3 times 5. And you can go ahead and plug this on the calculator. You get 60. This is the LCM. All right. All right, exercise 5. Again, I will prime factorize each of those numbers. All right, so I'll divide firstly here by 2, and we get 15. By 3, we get 5. And by 5, we get 1. All right, and here I will divide by 3, we get 15. By 3 again, we get 5. And by 5, we get 1. Here I'm going to divide by 2, we get 30. By 2, we get 15. By 3, we get 5. And by 5, we get 1. Now I'll write it out. So we have 30 is equal to 2 times 3 times 5. And 45 is equal to 3 to the power of 2 times 5. And the 60 is equal to 2 to the power of 2 times 3 times 5. And now for the HCF, I will select the common. So we can see here that 2 is not common for everybody. The 3 is common for everyone, and the 5 is also common for everyone. Second thing, I will select the lowest power for the 3. Lowest power for the 3 is just 3, and the lowest power for 5 is 5. So HCF is going to be 3 times 5, which is 15. All right, so hopefully this was clear. And the LCM, firstly, we select all the numbers, so 2, 3, and 5. And we select the highest power for each of them. So we'll select 2 to the power of 2, 3 to the power of 2, and 5. So my LCM is going to be 2 to the power of 2 times 3 to the power of 2 times 5, which gives me, let's see, 180. All right, let's take a look at the final exercise. We got 10, 25, and 30. And for the 10, we divide this by 2, we get 5. By 5, we get 1. Over here, by 5, we get 5. By 5, we get 1. And right here, by 2, we get 15. And by 5, we get 3. And by 3, we get 1. So now let's write it out. So 10 is equal to 2 times 5. 25 is equal to 5 to the power of 2. And 30 is equal to 2 times 5 times 3. All right, so for the HCF, again, we must select the common. 2 is not common between everyone, but 5 is. And that's it. Now, for second step is to select the lowest power of the 5. Right now, the lowest power is 5. And so the HCF is just equal to 5. Now, as for the LCM, first step is to select all my numbers, so 2, 3, and 5. And the second step is select the highest power. So for highest power of 2 is just 2. Highest power for 3 was also just 3. However, the highest power for 5 was 2. Right, so the LCM is equal to 2 times 3 times 5 to the power of 2. And this is 25 times 6, which is 150. All right, so that's it for finding the HCF and the LCM. Hopefully you understand the concept, and thank you for watching.